Okay, in this example, we want to solve and write the solution in interval notation. We have 5 over x squared minus 2x minus 15 is greater than 0. So the first thing we need to do is we need to make sure that the inequality or the rational expression is on the left side and 0 is on the right side. So for this example, the 0 is on the right side. Okay, so we're good there. But now we need to factor the denominator. So the denominator is not in factored form, but we want to be able to do that. So we have 5 over, okay, so if we want to factor this, okay, keep in mind that if you want to make your x, the value for c is negative 15, and then this is negative 2. So what two numbers can we multiply to get negative 15 that when we add them together, it's going to give us negative 2? Well, it's going to be a positive 3 and then negative 5. So therefore, our denominator is going to be x plus 3 times x minus 5, and we know that that's greater than 0. Okay, now we can then determine what are the critical points. So if we take a look at the critical points, then we need to look at what's in the denominator, because in the numerator we don't have an expression, we just have a constant. So therefore it's going to be x plus 3 times x minus 5, and that's equal to 0. So we have x plus 3, which is equal to 0, or x minus 5, which is equal to 0. So therefore x is going to equal negative 3, or x is going to equal positive 5. Now remember, this makes this undefined, both of these, right? So they are both are going to make the denominator undefined, so we need to keep in mind that that's what's happening. Okay, so in step number 4, what we have is now we have created this interval. Okay, so what does this interval tell us? Well, it tells us that we have two critical points. We have one at negative 3 and the other one is at 5. And then we're going to create our regions from that. So we have these lines dividing through those critical points. And we know we have region 1, we have region 2, and then we have region 3. Now let's determine what our intervals are. So we know that in region 1, our interval is going to go from negative infinity, and since this is negative 3, and we know it's greater than, it doesn't have an equal sign, and we know that it's undefined at negative 3, then that's going to have a parenthesis. So we go from negative infinity to negative 3. Okay, and then our second region is going to have the interval that goes from negative 3 to 5. So therefore, we're going to have a parenthesis at negative 3 and a parenthesis at 5. And again, because the 5 is undefined. And then we're going to go from 5 to positive infinity for region 3. So we're going to go 5 to positive infinity. Okay, so now in step number 5, what we're going to do is we're going to take testing points from each region. So if we take a look at region number 1, a number next to negative 3 to the left of that is going to be negative 4. So let's go ahead and choose x to be negative 4. Now, we can either pick the first inequality expression, or we can pick the second one. I'm going to go ahead and pick the second one. So we're going to have 5 divided by x plus 3 over x minus 5, and we're going to set that to be greater than 0. So we have 5 over negative 4 plus 3 times negative 4 minus 5. So we have 5, well, negative 4 plus 3 is negative 1. Negative 4 minus 5 is negative 9. Okay, and then negative 1 times negative 9 is positive 9. So you got to be careful with your order of operations to make sure that you're following that. Well, positive 5 over 9 is greater than 0. So therefore, we know it's going to be true for region number 1. Okay, now let's go to region number 2. We can pick the value of 0. So again, using the inequality expression, 5 over x plus 3 times x minus 5, and that's greater than 0. So we have 5 over 0 plus 3 times 0 minus 5. Well, that tells us that we have 5 over 3 times negative 5. That's 5 over negative 15, which reduces to negative 1/3. And negative 1/3 is not greater than 0, so we're going to say that that is false. So it's false. Okay, now if we go to region number 3, then we're going to pick the value, what's after 5, we can say 6. So again, we have the inequality 5 over x plus 3 times x minus 5 to see if it's greater than 0. So we have 5 over 6 plus 3 times 6 minus 5. So that becomes 5 over 9 times 1, and that gives us positive 5/9, which is greater than 0, so we know it's true for region number 3. So now we can determine what is our regions that say that it's true. Well, we know it's true for the interval negative infinity to negative 3, and we know it's true from 5 to infinity. So, knowing that, we can now determine that our result goes from negative infinity to negative 3, union 5 to positive infinity. And so therefore, there is our result.